Hi students, welcome to Alpha C learning program Mathematics. In previous session students, we have discussed about position of a line with respect to a parabola. Okay, position of a line, then we have observed a quadratic equation, and in that about discriminant less than 0, greater than 0 and equal to 0. Whenever discriminant is equal to 0, we have decided the condition is actually what there for parabola y square equal to 4ax, and if you consider the line y equal to mx plus c, then we have observed here discriminant is equal to 0, and that discriminant we have observed how much there, it is a equal to how much, or c equal to a by m. Okay, that implies a equal to cm. So this kind of condition we have observed while discussing about here the position of line with respect to a parabola. Now c is a by m we can observe for this kind of line. That implies what? Whenever discriminant is equal to 0, discriminant is equal to 0 to a parabola, suppose this one, then the line is here exactly touching the curve at one and only one point. Exactly it is touching the curve at one and only one point, and this point already we know it is nothing but point of contact, and the line is nothing but what here? Tangent line. Okay, therefore whenever y equal to mx plus c touches the line y square is 4ax where c equal to a by m, then we can say this line is nothing but a tangent to the parabola standard form y square equal to 4ax. Then what about here? Point of contact. How to obtain here point of contact? This point of contact means already you got here a quadratic equation, that means by substituting here y value is mx plus c our tangent suppose, then x value if I substitute y minus c divided by m, therefore this equation now it will become y square is equal to, okay, y square is 4a into, now x value it is nothing but y minus c whole divided by m, right? And now this m value if I do cross multiplication, my square is, it is 4ay and minus 4a into c. And now let us substitute c as a by m, because this line we have taken as tangent. As it is tangent, therefore I am writing this is 4a into c is nothing but a divided by m. Now again if I take LCM, then you will get here m square y square minus 4am and plus 4a square is equal to 0. Okay, so this kind of equation you can obtain by taking m as here LCM, and after that cross multiplication, this is our value. Now here we got exactly a perfect square, that is nothing but how much here, it is my, and next value minus this is 2a. Okay, my minus 2a whole square is equal to 0. That implies y equal to how much here? 2a divided by m. Therefore, to this parabola, if y is mx plus c is tangent, then the ordinate value you got exactly how much? 2a divided by m. Then what about here? The abscissa. Abscissa you can substitute here y value, and that is 4a square by m square, then obviously we will get here x equal to a by m square. So finally students, we have observed here when y is 2a by m, again if you substitute here x value how much you can get? A divided by m square. Therefore, the point of contact is nothing but a by m square comma 2a by m to the line y equal to mx plus c when it is tangent to the parabola. So this one is our first condition, y is mx plus c. Suppose the equation of line to the parabola, if it is touching like this, then the condition is here c is a by m and the point of contact is nothing but a by m square comma 2a divided by m, right? And sometimes line may not be in this way, then we have to this way. Usually we come across the line equation, every time instead of converting in this form directly you can put as it is, and thereby you can make use of this condition. So what is the other line actually? Lx plus my plus n is 0. Okay, so Lx plus my plus n equal to 0 if I write, and this is the line Lx plus my plus n is 0, and now we want to convert it exactly in the above form. To that purpose my is nothing but how much here? Minus Lx minus n, and if you divide by m, then this is y equal to minus L by m and into x minus n divided by m. So now you got y is mx plus c type. Okay. Once this is y is mx plus c type, then what about here our standard form? I am taking here m equal to minus l by m, and next c equal to here minus n by m. Okay. So these are the values. Now the line is actually y is mx plus c. And now here what is our condition? If this is a tangent line, c equal to a by m. So here c equal to a divided by a, same value we are taking, m means suppose capital M. Now what is that capital M here? It is nothing but how much? Minus L divided by m. Okay, minus L divided by m, and in the place of c we are having how much? Minus n divided by m. So minus n by m is equal to a into a divided by m, and that m value is here minus L divided by m. So let us cancel here m and m values, and thereby this value goes up. That implies it is n divided by m is equal to am divided by L. Then if you do cross multiplication, am square equal to you got ln. So that one is here the condition for tangency when the line is here lx plus my plus n is 0. Therefore if the line is of this form like 2x minus y plus 3 equal to 0, which is a tangent to this kind of standard form, then directly you can write am square is ln. A is from here, m is y coefficient, L and n are here x coefficient and constant respectively. Then in this case what about again point of contact? In the same way if you substitute, this is the standard form actually we have taken earlier, a by m square 2a by m you got, and the same formula if you substitute here simply you can obtain this is the point of contact. Okay students, so now whenever the parabola is y square is 4ax, then if the line is of the form y equal to mx plus c, we have observed here condition for tangency as well as this is our point of contact. And if it is of this form, then this is condition for tangency and this one is the corresponding point of contact. And sometimes here the vertex may not be exactly origin. If the vertex is exactly here in this form, that is alpha comma beta. If vertex is like alpha comma beta, then equation of tangent can be written as here y is mx plus c. Understand, y is mx plus c implies here in place of y we are having y minus beta, and in place of x here you are having x minus alpha. And if this is a tangent, already declared it is a tangent. If it is a tangent, this c has to be here a by m. That means if you write this one is tangent here, then what are conditions here? Y minus beta is m into x minus alpha plus a by m. Then in this case, what about here? Point of contact. The point of contact also to this value, okay, to this value exactly add how much here? Alpha comma beta. Therefore, in this case, the point of contact is nothing but how much? A by m square plus alpha comma 2a by m plus beta. Okay, so this will be exactly the point of contact of this kind of tangent to this kind of parabola. So the same old formula only you are using, but just how much we are adding the vertex, that is alpha and beta. Okay, and next one, it is suppose sometimes many problems we come across like this. Okay, no beta value, it is origin, and many times we come across this kind of parabola in our problems. Then if this is a tangent, then what about the condition? Same here, just beta is absent, that is 0, and now m into it is x. X means here you are having x plus a, and as usual plus a by m. Therefore the same condition actually we write y is mx. Okay, I am distributing m value inside plus am and plus how much it is? A divided by m. So this is the value. That means here what is the c value, students? If it is of the form y is mx plus c, then c is nothing but am plus a by m. Therefore whenever y is mx plus c is tangent to this parabola, then the condition for c is nothing but am plus a by m. Easily to remember here, just the tangent is nothing but y is m into, in place of x you are having here x plus a, and C is nothing but how much here? A by M. Okay, so these values are very important, especially this one. Many times it visits in our problems. Okay, so remember this one as formula also. So what is the tangency condition here, students? C equal to AM plus A by M. So this is tangency condition for the line y is mx plus c to this parabola is a tangent. Okay, and next one, for a parabola x square equal to 4ay. Okay, every time they may not ask this one. Sometimes they may ask about x square is 4ay also. If y equal to mx plus c is tangent to this equation, then what is our condition actually? Simply we substitute here mx plus c, we substitute here, and thereby you can obtain a quadratic, that is x square is 4a into, I am writing this as how much here? Mx plus c. That implies x square minus 4a mx and minus 4ac equal to 0. Okay, so you got a quadratic equation if this line is here and intersecting or whatever position of line just we have taken. If this is exactly the tangent line, then discriminant has to be 0. So here what is the discriminant? B square, that is 16a square m square b square minus 4ac, that implies 16ac into 1. So this value has to be 0 for the line to be tangent. Okay, for tangent this is the condition. Then here 16a if you divide, then you will get here a m square, and what about here? Minus of minus you got here plus, and this one is plus how much you got? C equal to 0. That implies C is equal to how much here? Minus am square. Therefore nothing to worry here about what about the condition etc. I couldn't remember the formula. Concept is very simple, that is whenever a line is tangent to a curve, just substitute the line in the curve equation and thereby you will get a quadratic equation, and that quadratic equation take discriminant as 0 for tangency condition. Okay, and in that value here if you divide by 16a, then you can obtain this condition. So this is our tangency condition when the line is tangent to this curve. Okay, now again point of contact also, however we found in this case, in the same way here you can find point of contact. At the same time Lx plus My plus n is 0. Suppose if it is coming, then this is the tangency condition. Okay, this is our tangency condition and this is our point of contact. Proof is just now, however we have done, in the same way we can proceed. So students, these formulae are essential, because don't think that always our problems are only numericals. Sometimes those are even conceptual also, like that they ask about locus etc. That time actually if you remember the formula, well and good, easily you can complete the problem within a short time, right? So these formulae remember. And the next one is here the actual tangent equation at a point. Okay, these are all we have discussed using what concept actually? Position of a line with respect to a parabola. Using that concept directly we can derive all these conditions. But actually what is equation of tangent? Okay, at a point here prepositions are important. One concept is at a point and another concept is from a point. Okay, from a point is there, at a point is there. So you have to read these tangent problems very carefully. Are they asking at a point or are they asking from a point? Okay, now we are going to find here equation of tangent at a point. Okay, in case of circles you have taken directly, if a chord is taking, that is it is a of x1 comma y1, and if this is b of x2 comma y2, then the chord if it is moving and it is moving in certain way, that is here if b reaches to a, okay, if b reaches to a, then the chord position will be slowly what will happen here? Exactly like a tangent. Okay, when b is tending to a, then we know here tangent chord equation with x1 y1 x2 y2 endpoints is nothing but S12. This is our chord equation. Now what we are taking here, this x2 y2 is tending to x1 y1. That implies limit here it is nothing but x2 comma y2 is tending to x1 comma y1. In that case what is this value? S1 plus S2, and RHS also same value we are writing. That is the limiting case of here chord equation. x2 comma y2 here tending to x1 comma y1, this is S12. Then x2 y2, here there is no x2 y2, limit of a constant is constant, so we write it as s1 as it is. And now x2 y2, here if I substitute as x1 y1, it is plus s1, and now it will become how much it is, s11. Okay, but where is the point here? Whenever we have taken tangent at a point x1 comma y1, okay, x2 y2, x1 y1 both are here on the curve. Whenever it is a point is on the curve, then S11 you know very well it is 0. Therefore you got here 2S1 is 0 and hence S1 is equal to 0. Hence we say here the equation of tangent to the curve S equal to 0 at x1 y1 is nothing but S1 is 0. So this one, actually this formula, not only to the standard form, to any second degree equation we can make use of this kind of formula. So what is our formula, students? The equation of tangent, okay, the equation of tangent at x1 comma y1. So here what is the important thing you have to observe carefully? It is nothing but at. So in your notes also you just here underline at the point x1 comma y1 to any curve s equal to 0, okay, is what is our formula? S1 is equal to 0. So whenever they ask about not only the standard form, suppose a parabola is given oblique one, that is x square plus y square plus 2xy and minus, suppose it is given as 3x etc. equal to 0. Suppose this kind of equation is given. Understand, if this kind of equations given, then simply we can say here to this, what about equation of tangent at certain point they will ask, suppose it alpha beta, okay. So tangent at alpha beta you can make use of here how much, S1 is equal to 0 when this is our curve S value. That implies what is the equation, xx1 plus yy1, and after that we have done this part, half the value you have to take, and just like our differentiation formula we apply x beta plus y alpha, right, x into y1 plus y into x1 and minus here 3 by 2 and into x plus alpha plus constant is 0. If you simplify, this is nothing but our equation of tangent at a point. So this is very very important, students. At a point we will get one and only one tangent, okay, one and only one tangent. This one is at a point x1 comma y1 to a curve s equal to 0. So finally what is our formula? The equation of tangent at x1 y1 to s equal to 0 curve is nothing but s1 equal to 0. Now once we got this formula, then what about our standard parabola? Okay, to the standard parabola y square equal to 4ax. So I am taking here s is nothing but how much, y square equal to 4ax. So y square minus 4ax is our standard form, right? And now at x1 y1, what is our formula? y1 minus 2a into, it is x plus x1 is equal to 0. Okay, now if I do simplification, y1 is nothing but 2a into x and plus 2a x1. So this is our final equation of tangent. Then we have a lot of interest on parametric coordinates. Actually in parabola lot of importance is there for parametric coordinates. And what is our x1 to this standard form? It is 80 square and y1 is how much here? 280. Therefore at x1 y1 if you take the points as 80 square comma 280, right, and substitute here y into y1 means it is 280 and this is equal to 2ax plus what about this value here, 2a x1, that is 2 into here a into a t square. So this is the value we can substitute. Now throughout you can divide with what value, 2a, then yt equal to x plus how much we got, a t square. So this is a very very important equation. Yt is x plus at square. Every time don't think that okay I can derive at the time of exam. In that way don't think. You have to remember remember this kind of formulae. Okay, yt is x plus at square. Students, observe here, what about the slope of this tangent? That means our interesting question is nothing but what is equation of tangent, that is one thing, and the other one is about slope. So that is very important. If I write this is y is 1 by t into x and plus this is at square divided by t, it is of the form y equal to mx plus c. Okay, so what is slope of tangent here? The slope of tangent at t. Okay, so slope of tangent at t to the parabola y square equal to 4ax is, what is the value here? 1 by t. A very important condition. Okay, now actually this you can observe even from our chord slope also. What is the chord slope we have derived earlier? The slope of chord joining 2 points. Okay, slope of chord joining 2 points is nothing but 2 by t1 plus t2. Understood? And now here in this actually from slope of chord, this is our t1 parameter, t2 parameter, you got this kind of value. Then actually what is happening now for tangent? T2 is tending to T1. Okay, T2 is tending to T1 implies 2 by T1 plus T1. So 2 by 2T1. That implies it is nothing but 1 by T. Okay, so in this way also we can derive, students. So finally, what is our formula here? The equation of tangent in parametric form. That means if this is the parabola y square is 4ax and if this point is at square comma 2at, then the tangent equation, what is our derivation? Y t equal to x plus how much? At square. So this is the point of contact and this is the tangent to the parabola y square equal to 4ax. Okay. Now you observe even from this also, what is slope actually? M equal to 1 by t, right? M equal to 1 by t. That implies t is 1 by m. Okay, t is 1 by m. So 1 by m square implies at square. 1 by m implies t. So you got exactly at square 2at. And in that way usually you observe this condition also. Here m means 1 by t, you substitute. C means a into again it is t, if you substitute you will get again this kind of equation. So students, observe here, this is one of the important things in our parabola, equation of tangent at a point t. Okay, then what about here this equation? X square is 4ay. Now you know very well these two parabolas, they have a relation, that is they are, one is image of the other with respect to the line y equal to x. Okay, so one is image of the other with respect to y equal to x. Therefore to this parabola y square equal to 4ax, if tangent equation is yt equal to x plus at square, then what about here? To x square is 4ay parabola. Okay, to x square is 4ay parabola. It is nothing but image with respect to x implies just interchange x and y. That means xt equal to now how much? Y plus at square. Just interchange here x and y. That is nothing but here equation of tangent to the parabola x square equal to 4ay. Then what about here also? The point is nothing but here how much? 2at comma at square. At this point you can say this is our tangent equation. Okay. So now basing on these concepts, let us have a glance on these problems. Now first one is equations of tangents at ends of latus rectum to the parabola y square is 4ax. Okay. Now we will have a lot of interest. What about here? Tangent. Okay, at ends of latus rectum. Suppose let us take here the standard form y square equal to 4ax. And this is our standard form. Suppose this is the latus rectum LL dash. So what about here? This is a comma 2a and this value is here nothing but L dash a comma minus 2a. So these are ends of lattice rectum, and remember to the standard form y square is 4ax. Once a comma 2a is one end of the lattice rectum, then what about the parameter t? Okay, so if you compare 2at equal to 2a implies t equal to 1 here. Okay, so t is 1 clearly we got. In the place of a we have a, and here t is how much? Minus 1. Okay, so you can do any method, but I am doing here with this method, and you can use here directly s1 is 0 concept you can apply, or y is mx plus any here concept you can make use, but now I am using here the parametric form because clearly you know t equal to how much here? 1. So remember students, y square is 4ax parabola, always here ends of lattice rectum if you take, then t value is nothing but 1. Now what is our standard formula? Yt equal to x plus at square. Okay, so this is our formula to this kind of parabola. Then at t is 1, therefore y equal to how much here? X plus a. So this is one end of lattice rectum, that is tangent at one end of lattice rectum. And next the other one, at t is minus 1 if I take, then it is y into minus 1. So minus y is x plus t minus 1 whole square means again it is same value. So minus y equal to x plus a. Clearly you can understand these two lines are intersecting, right? These two lines are intersecting exactly at what point here? If you add them at x is minus a, okay? And now here this is the other tangent we can say. So don't misunderstand that wherever tangents are taken at ends of lattice rectum, those are not parallel, okay? Moreover, those are perpendicular actually. If I take this is one tangent and this one is another tangent like this. Now this is at L dash we have taken, this is at L. These two are right angle. How we can say right angle? Here the slope is 1 and here the slope is minus 1. So product of slopes is minus 1. Therefore you got here these two lines are always at right angle. So you can remember students always the tangents drawn at the ends of lattice rectum, always they are at right angle. Moreover, this point of intersection is nothing but on directrix. How you can say on directrix here? If you add these two, x plus a value 0. X plus a 0 means what is that value? X equal to minus a. So where is that x is minus a? This is nothing but our directrix. Okay, so directrix equation is x is minus a. Therefore we can say this is one tangent we got, y is x plus a, and this is another tangent, y is minus x minus a. And if you substitute here minus a, here x value and this other value also we can obtain. Okay, next one. What about the second problem? Equation of tangent inclined yet, okay, inclined yet 30 degrees to the axis of parabola, y square equal to 8x. Okay, so y square is 8x. What is our 4a value here? 4a is 8 implies a equal to 2 here. Okay, to the second problem. And what is theta given to the axis? You know, to the axis means to this parabola axis is nothing but x axis. Therefore here inclination given as 30 degrees. 30 degrees means tan theta is our slope. So m equal to tan theta equal to how much here? It is tan 30 degrees. Now tan 30 degrees means you know the value is here 1 divided by root 3. Okay, so m value given, this is 1 by root 3. In other words, we can use even 1 by t equal to 1 by root 3 also. Anyways, you can solve the problem students in the parametric or y is mx plus c in both the methods. So suppose I am taking like this, m is 1 by root 3, a value, therefore one of the forms is y equal to mx plus it is a by m. This one also you can take as tangent, or you can take it as yt equal to x plus at square. This also you can use where what is our m is 1 by t, so t is here root 3. So anyways you can use that. I am taking here this form directly because inclination is there. Now y equal to this is x divided by root 3 plus a means it is 2 and divided by 1 by root 3 implies this is our equation of tangent. So what is the data given in the problem? to the standard form y square equal to 8x. The inclination is given, and once inclination given, slope is tan theta, that is 1 by root 3, and we substituted here y is mx plus a by m. This is our tangent actually for this parabola standard form. M value we substituted, and here again a and m both we have substituted, right? And next one, third one, if the line touches a parabola, then what about here k value? Okay, sometimes you may feel here how I can remember these many formulae. Okay, these many formulae, that means we can remember to this standard form, tangency condition, point of contact, everything. But what about here? So nothing to worry. Even then also, if you can remember, it is well and good. If not also, nothing will happen. That is, simply you substitute y value, how much here you are having, 3x plus k, that value you substitute and thereby make use of discriminant as 0. So let's do, students, both the methods. One is without using formula. Okay, so what is the curve given? X square equal to 4y given, and what is the line given? It is y equal to 3x plus k. Okay, y is 3x plus k. Now I am substituting this y value here. Okay, x square is 4 into 3x plus k, then it is x square minus 12x and minus 4k equal to 0. But they are telling that the line is touching here, which one? Touches. This line is touches the curve. Touches means you have to use discriminant as 0. Okay, so discriminant is 0, that is here what is discriminant? B square and minus 4ac. 4 into a is 1 here and c is minus 4k. Okay, so this is our value, this is equal to 0. So b square minus 4 into ac we have taken. So this is our value. Now this is 16k and equal to how much it is? Minus 144, and hence k equal to here minus 9. Okay, so in this way easily you can get even directly using the quadratic concept. And what about here? Formula, if at all you want. What is our formula? If you reduce like this, then use this formula, and if you reduce as it is, if you put in this way, then make use of this formula. Okay, so if I write Lx plus my plus n is 0 as it is without writing y equal to, then what about that method actually? That is 3x minus y, okay, plus k equal to 0. So here L is how much? 3, m is how much? Minus 1, and n equal to k. Then if you substitute al square is mn, so this is our condition, al square equal to mn. A value we got how much here? 4a equal to here 4, and that implies a is equal to 1. So a value we got this. Now I am substituting 1 into L square, that implies 9, and equal to m. What is m value? Minus 1, and into n it is k. So a k equal to how much here? Minus 9. So in any ways you can do here, once you can remember the formula well and good. Otherwise also just make use of here quadratic concept. And next one, students, to this parabola y square is 4a into x plus a. Okay, y square is 4a into x plus a. If it is having a slope minus 2, if it is having a slope minus 2, then what is equation of tangent? Okay, so what is equation of tangent they are asking. Now here also you can make use of one concept, that is y equal to one of the methods you can use y is mx plus c, and here m is given as how much in this problem? Minus 2x plus c. Okay, then this value, y value you substitute, or x value you substitute here, and thereby again get the quadratic equation in x or y and make the discriminant as 0. Thereby you can obtain the unknown and again substitute here. And the other method also there, that is directly you know about this method. What is our tangent equation? If the line is curve is given as y square is 4a into x plus a, Okay, what is the tangent equation we observed? It is y equal to m into, instead of x we are having x plus a, and after that what is the next value we got? It is nothing but a by m. Okay, because this is representing the standard form of parabola. Just now we have observed this formula also. Better remember this one, because this kind of curve repeat many times in our problems. Make use of this one. Now in this problem, students, what is the slope given in the problem? Slope of tangent is given as -2 and rest are all as it is. That means here y equal to -2 into x plus a, okay, plus a divided by -2. Then if you simplify, that is our final answer, because in the data already a value is given. Okay, simply you can make use of this relation to obtain the equation of tangent. Okay.